So n is a positive integer. Is n odd? First, when n is divided by 3, remainder is 1. So now we can write this as n is equal to 3 into some integer plus 1. Now 3 into some integer can be even also, can be odd also. So plus 1 can be even or odd, both. This is not sufficient. Second, n divided by 8, remainder is 1. 8 into anything, even integer into any other integer would always be even. So plus 1 will always be odd. So this is sufficient. Okay, B0 answer. Second statement is sufficient. B0 answer choice. X divided by 101, remainder is 5. Now x square divided by 101, remainder will be, we can multiply the individual remainders. That will be 25, 5 into 5. X cube divided by 101, 5 into 5 into 5, that is 125. We divide it once more by 101, 24. X divided by 101, it's simply 5. So x cube plus x square plus x divided by 101, we can add the individual remainders. Okay, so that will be 54. Now if you see, the same thing goes here. T square plus 5t plus 6 divided by 7, what is the remainder? Now the way in previous question, if x by 101 remainder is there, we can find x square by 101 remainder, we can find x cube by 101 remainder. Same way we can find t square by 7 remainder. Yes. 5t by 7 remainder. Yes, 5 by 7 remainder into t by 7 remainder. So we can find this also. 5 by 7 remainder would be 5, and 6 by 7 remainder we can find. So you can find everything that is required here. This is sufficient. We don't need to find anything. Second, t square by 7 remainder is 1. Now again, what we need is t divided by 7, what is the remainder? That is the question. If we know this, we can find everything. Now if t is equal to 1, this condition would be satisfied, and t by 7 remainder would be 1. If t is equal to 6, still this condition would be satisfied. T square by 7 remainder would be what? 36 by 7, 1. But if t is equal to 6, still this condition can be satisfied, which is t square by 7 remainder is 1. So t by 7 remainder in this case, when t is equal to 6, would be 6. So you can have different values of t by 7 remainder. So this is not sufficient. N is positive, R is the remainder when 4 plus 7n is divided by 3. So 4 plus 7n divided by 3, what is the remainder? 4 by 3 remainder is known to me, yes. 7 by 3 remainder into n by 3 remainder. So what all I need is 4 by 3 remainder. N by 3 remainder, sorry. First statement, n plus 1 divided by 3, okay, it's 0 remainder. That means n plus 1 can be a number like 12 or 15. Okay, so n will be a number like 11 or 14. So divided by 3, remainder in all cases here would be 2. Okay, try with any number. That means n by 3 remainder is known to me, so this is sufficient. Second statement, n is greater than 20. Now n greater than 20 It could be 21, 22, 23, 24, anything. So remainders would be different. It will be 0, it will be 1 here, 2 here. So this is not sufficient. So A is your answer. Okay, so when we find last digit of an exponent, 3 raised to the power 4n plus 2 plus m by 10, what is the remainder? So when something is divided by 10, let's say 24 is divided by 10, what is the remainder? 4. 121 is divided by 10, remainder is 1. So when something is divided by 10, remainder is always the last digit, the units place digit. So that means we need to find last digit of 3 raised to the power 4n plus 2, and we need to find last digit of n. If we know their last digits, we can just add them simply. Now 3 raised to the power anything. Okay, let's say 3 raised to the power x. How do we find the last digit? X divided by 4, and we check the remainder. So 4n plus 2 divided by 4. N is a positive integer. Now 4n plus 2 by 4. 4n will give me 0 remainder. N can be anything. 4n by 4 will be divisible. So remainder here will be 2 always. Okay. So this last digit is fixed. It's not dependent on the value of n. N can be anything. So last digit would be fixed. Okay. So what it depends on is simply the value of m. That's what I need. First statement, not sufficient. I don't need value of n. Second statement, a value of m. That's what I need. So B is your answer. That is sufficient. So let's say D, the decimal is ABC dot XYZ. What we need is 100th digit, that is Y. Is Y greater than 5? That's our concern. First statement, if we take 10D, so what happens with 10D? So decimal will shift 1 to the right. So 10th digit of 10D, 10th digit here would be Y is given as 7. Sufficient? That's what we needed. Second, D by 10. D by 10 would be AB dot, the decimal will shift 1 to the left. So we know 1000th digit. 1000th digit again would be Y. Y is given. So this is also sufficient. D is your answer. Okay, so x is rounded to the nearest 100th. What is the problem? So when x is rounded to the nearest 1000th, the result is 0.455. So x could be 0.4554. So that when we round it off to this place, it becomes 0.455. And it can be this also, so that we round it off to this. Next number is bigger than 5, so it will also round off to this place. Now the question is, when x is rounded, x means the original number x is rounded to the nearest 100th. So this way it will become 0.46, because the next number is 5 or bigger, and this would be 0.45 because the next number is less than 5. So you can get different results after rounding off to the 100th place. This is not sufficient. Okay, the concern here is the 1000th place is 5 or 4. That's the concern. Second statement is the 1000th digit is 5, but we don't know other digits, because the question is what is the result, what is the final number after rounding off. So this is not sufficient. Combine the two. The concern in first statement was whether 1000th place is 5 or 4, because the difference was only because of that thing. That is taken care of by the second statement. 1000th digit is 5. So this will be sufficient. So C is your answer. So fraction P by Q. Now if you take a fraction like 1 by 2, it will have finite number of non-zero after decimal, like it will be 0.5 and then 000. I mean it'll terminate somewhere. Same way 1 by 5 will also terminate. So in the denominator, if we have only 0, 2, 5 and their exponents, it will terminate. It will have finite number of non-zero things after decimal. But if the denominator has any other thing like 3, 7, 11, anything other than 0 and anything other than 2 and 5, so it will become non-terminating. So that's what we check. So if you see, second statement itself is not sufficient because it talks about only the numerator. Okay, so because what we are checking is denominator, so this itself is not sufficient. What it simply tells me is P is a multiple of 25, so it will be some integer which is a multiple of 25. First statement tells me Q is a factor of 1000. So 1000, it can be written as 2 cube into 5 cube. So factors of 1000 will only have 2, 5 and their powers, their exponents, will not have anything else. Okay, but there is one concern here. It looks like that the denominator has only 2 and 5 and their powers, so it should be terminating. The concern here is P. We don't know anything about P. P could be 5 also, some integer. P itself could be a fraction like 1 by 3. Now if P is 1 by 3, you can divide it by anything, any integer, it will become non-terminating. So if it is an integer, it will be terminating. If it is a fraction, it can be non-terminating. So this itself is not sufficient. Combine the two. Problem in first was whether P is an integer or not. That is taken care of by the second statement. Multiple of 25, multiple of any integer means it has to be some integer. So that is sufficient. C is your answer. So in this question, if you look at the answer choices, they give me range. Range means upper limit and lower limit. So m is equal to 1 by 201, 1 by 202, 203 and so forth. So let's say all the terms, so it will be till 1 by 300. All the terms are if 1 by 200. So the sum would be 1 by 200 and 200, 1 by 2. But actually the terms are lower than 1 by 200. So the sum would be lower than 1 by 2. Okay. Now if all the terms are 1 by 300, each term is 1 by 300. So the sum in this case would be 1 by 300 into 100, 1 by 3. But actually every term is bigger than 1 by 300. So the sum would be bigger than 1 by 3. So in this question, every term is given by minus 1 raised to power n plus 1 into 2 raised to power minus n. So n is any integer from 1 to 100. Okay. For example, if we're talking about first term, we'll put n is equal to 1 and so forth. So in such case, just write first 5, 6 terms. It will be 1 by 2, minus 1 by 4, 1 by 8, minus 1 by 16, and so forth. So again, we need to find a range for the sum. Now if you take 1 by 2, what will be sum of last two terms, the next two terms, minus 1 by 8. Sum of next two terms, minus 1 by 32. Sum of next two terms will be minus 1 by 128 and so forth. That's 1 by 2 minus some small numbers, very small fractions. If you see, the value of fraction will keep decreasing. So the sum has to be less than 1 by 2 for sure. Be it a very small difference, but it will be less than 1 by 2. Same way, so let's say these are the few terms. Sum of first two terms is 1 by 4. Next two terms 1 by 16. Next two terms 1 by 64 and so forth. So it will be 1 by 4 plus something. Be it a very small value, but it will be more than 1 by 4. Sum is more than 1 by 4. So it will be between 1 by 2 and 1 by 4.